Alright, for adding and subtracting radicals, the same conditions need to be true as when we were multiplying and dividing. The indices need to be the same. So again, you can't add a square root and a cube root or a fourth root and a square root. They need to be the same type of root in order for you to add them. The thing that's different though is that you actually have to simplify first. So if you guys remember from last class, we multiplied the numbers together first and then simplified the results. It's the reverse for add subtract. You need to simplify every term in your problem. You need to simplify them first, and then if they have the same radicand, the same number on the inside, then you can add them. It's like combining like terms. So again, the conditions for addition, the indices and the radicands, that means whatever is inside of the radical, those need to be the same in order for you to combine them. So remember, the idea is combine like terms. That's what we're going to be focusing on again for addition and subtraction. That's really what we focus on all the time. If I were to give you something like 2 plus x, would I be able to call that 2x? Why not? Because they're not like terms, right? What if I had x plus x squared? Would I call that x cubed? No, because they're not like terms. Same thing as if I had square root of 2 plus the square root of 3. Would I be able to call that the square root of 5? No, because they're not like terms. So that's what I'm really talking about, that same idea. You guys are really easy to catch that on these two examples. We're going to apply that the same way with radicals, okay? Now, the way that it's different, what if I had done what if I had done 2 times x? Can I multiply 2 times x? Yeah. Can I multiply x times x squared? Yeah. Can I multiply square root of 2 times square root of 3? Yes, the idea of like terms doesn't apply to multiplication. It only applies to addition and subtraction. So that is something you guys will have to remember.
Wait, you mean the opposite? Multiplication works for...
Combined like terms does not apply to multiplication, but it does for addition and subtraction. Is that not what I said?
No.
So again, to add, the directions are here. You're going to fully simplify both, or there could be more than 2, however many radicals you're adding. Simplify them completely. Alright, all the way. They have to be simplified all the way. And then, if the radicands are the same, then you can combine them like they're like terms. But what you're doing is when you combine like terms, let's say I had 2x, this is kind of going back to what you guys are more familiar with. If I had 2x plus 3x, what would that be? 5x. What parts of those were you actually adding? The 2 and the 3. The x is the like term, right? So the x remains the same, you're just adding what's in front of the x. So for example, if I had 2 square root of 2 plus 4 square root of 2, what do you think the answer would be? Add. I have 2 square root of 2 and 4 square root of 2. So if you had 2 of these and then 4 of these and you add them together, then you have 6 of them, so it would be 6 square root of 2. So just like when you add like terms for this example where you don't actually change what it is that they have in common, it's the same thing for radicals. So you're only going to add the outside numbers, just like we added the 2 and the 3, and the 2 and the 4. That's the same pattern you're going to follow. You're going to add whatever's on the outside together and leave that on the outside, and then the common radicand does not change. Okay? So again, it's combining like terms or like radicals. So here's an example right here of square root of 12 plus 5 square root of 3 minus square root of 3. So you're going to go one at a time and simplify them if you can. So obviously we know that 12 can be split into 4 and 3. So when you take the square root of 4, it becomes 2 on the outside, 3 on the inside. Are all of these like terms?
Yes.
Yes, they are, because they're all square root of 3, square root of 3, square root of 3. As long as whatever's inside of the radicand is the same, they're like terms. So I have 2, then I add 5, and then I take 1 away. So if I had 2 and then 5, that's 7. And then you take away 1, that's 6. That's the idea that we're working with, okay? Here's another one. This one has variables now. So again, you look at each one of them and simplify them if you can. The first one can't be simplified. But if you look at the second one, this is a cube root this time, so we need to split 24 into its factors, where one of them is a perfect cube, which would be 8 and 3. So then the cube root of 8 comes outside as a 2, and then the 3 is on the inside. Are these like terms? Yeah, because they both have 3x on the inside, 3x on the inside. So then, because they're like terms, you have 5 of them, and then you take 2 of them away. So then how many are you left with?
Okay. What if they weren't like
If they're not like terms, then, so let's say if this was like a 2, a 2x,
two? It's just not.
you just leave it. If you can't combine them any further, you just leave them as that expression. Okay? Does that make sense in general? Okay. So let's go ahead and practice with these examples that are down here. So again, you have to simplify first and then try to combine them. Almost always, the original question, they're not going to be like terms. But don't panic, because after you simplify, a lot of the times they will become like terms. So, can I simplify 2 square root of 8?
No.
Yes, because I can split 8 into 4 and 2. The square root of 4 is 2, comes outside to join the 2 that's already there, so they multiply to become 2. Again, we practiced simplifying last class, so I'm assuming you guys are kind of rolling with that. So we have 4 square root of 2 now. Can I simplify 2 square root of 2? So that stays. Can I simplify 2 square root of 24? Yes. I can split that into 4 and 6. The square root of 4 becomes 2 on the outside, so I have minus 4, and then square root of 6. Alright, do we have any like terms in here? Are they all like terms? No. So what you're going to do is really only have some of them are like terms and some of them aren't. You're only going to combine these 2 together and leave that one alone. So if I had 4 square root of 2's and then I add 2 square root of 2's, I would have 6 square root of 2's minus 4 root 6. Those are not like terms, so I have to leave them as an expression. Okay? Alright, what about this one? Can I simplify 2 square root of 18? Yep. What 2 numbers would I use? Nope. 9 and 2, because we want a perfect square. 9 and 2. Take the square root of 9, 3 comes out on the outside to join the 2. What happens when the 3 and the 2 meet? It becomes 6. So it's 6 square root of 2. Alright, how would I simplify 24? What?
Why is it 6?
Because you're bringing the 3 out to meet the 2 and they multiply, just like we talked about last class.
But so we're doing it 2 times 3.
Yeah, because the square root of 9 is 3. What?
So you do the square root of whichever
Hold
is.
on. Your question? No, because you're adding 4 plus 2 is 6. What's your question again?
So the square root of 9 is 3.
It's 3. And it goes outside to join the 2. 2 times 3 is 6.
Okay, so we do that for every time.
Yes. That's just simplifying. Remember, simplifying is first, then once you simplify everything, you can combine like terms. Simplifying is the same, no matter what the context is. Alright, we simplified the square root of 24 just like we did over there. 4 times 6. Square root of 4 is 2. So I still have 2 square root of 6 for that one. Simplified the same as the previous question. And then we have 54. What 2 numbers can I use for 54? So 36. Nope. 9 and 6. 9 is a perfect square. The square root of 9 is 3. So when you pull out the 3 to join the other 3, combined, what are they? 9. And then you have the square root of 6 on the inside. Alright, so do we have any terms that we can combine?
Yes.
Which ones? Okay, so if I have negative 2 square root of 6's, and then I subtract 9 from that. Negative 11. So the 6 root 2 stays, and then I have 11, negative 11 square root of 6.
If you put it to the right, then you just like plus 6 square root.
You would have to have negative 11 square root of 6 plus 6 root 2. I don't know why you do that. Usually write it in the same order as it was presented. Alright, what about this one? This is going to have our perfect 4th power, so I did have a little list for you guys. Hopefully you looked at that. We'll see. What do I know about 64 when it comes to 4th powers? What is a perfect 4th power? From the list that you guys had. 16. Is 16 a factor of 64? 16 times. Okay, so what is the 4th root of 16? What times what times what times what is 16? 2. 2 times 2 times 2 times 2 is 16. So if I'm pulling out a 2, to join the 2 that's already there, it's 4, with a 4th root of 4 left behind. Don't forget to include the index. Can I simplify this middle term? No, it's too small. Just going to leave that alone. And then we already simplified the square root of 64 in the previous one, so I know exactly what to do with that one. The 2 comes out, that's another 4. Alright, sorry, my handwriting got a little squished. Alright, so now what do you think? All of these are like terms, right? Because now all of the radicals are the same, so I can just combine them together. So if I have 4, and then I take away 3, and then I take away 4 more, it would be negative 3. 4, 3, and 4. Okay. Alright, now we have cube roots this time. Bless you. What is a perfect cube that's a factor of 162? 27 and what? Okay, so 27 and 6. What is the cube root of 27? 3. So when I pull out 3 to join the negative 2 that's already there, it becomes negative 6. Cube root of 6. Does everybody agree that's simplified correctly? Alright. I can't simplify the middle term. I can simplify the third one. 48 can be split into what 2 numbers? 8 and 6. 8 being the perfect cube, what is the cube root of 8? 2. Comes out to join the 3, becomes 6. So this is 6. Cube root of this number is left behind 6. Alright, do I have any like terms? First and the last, so I have negative 6, cube root of 6, and then positive 6, cube root of 6. They basically cancel, leaving you with just the middle term. Okay? Alright, I'm going to let you guys try the second row by yourself. Or not second, but third one. See if you can figure out how to do those next 2. Alright, so hopefully you guys are done or close to being done. For the first one, you should get 2 cube root of 3 plus 12 cube root of 6. You should have 2 of each type of radical that can combine, but the cube root of 3 and the cube root of 6 can't combine. And then this example was a trick question. Alright, why can't I do this? Because only 2 of them are the same type of radical. So for this one, you could really only attempt to try to simplify the cube roots, but I think even after you try to simplify the cube root of 108, it still wouldn't be a like term with the cube root of 7. So you really can't combine any of them. I want you to say it's not possible.
Can you go over how you got and what you do with the negative 3?
Remember we talked about on day 1, whenever there's a negative inside and it's odd, the negative comes out. So that would be a negative 4 that comes out, so that becomes a positive 8 cube root of 6. Because the negative 2 and the negative 4 combined become positive.
So you say subtracting.
Right. The double negative turns into positive.
So whenever it's inside, it's not going to
So again,
inside the whatever it's called.
when the negative is inside the radical and index is odd, the negative will come out when you simplify. And then if it was subtraction, it would turn to addition. It's a double negative changes. Alright, so those were a bunch of examples where it's just numbers. Now we're going to see a bunch of examples where there are variables in the mix. So the rules still apply. Whatever's inside of the radical has to be completely identical between the 2 radicals in order to combine them. So this is just a really basic example. Are these two like terms? Okay, I have 18 of the square root of 3x, and then I take 6 of them away. So I would have 12 square root of 3x left over. Over here, not quite as straightforward. From first glance, it looks like you can't add them because they're not like terms. But remember, what do you always do first? Simplify, because after that they may become like terms. So I can't read this very well. Sorry. Okay, so that's 54. What is a perfect cube? That's a factor of 54. 27 and 2. So 27 is the perfect cube. Cube root. 3. So now I have 3. Leave some space, and then the cube root of 2. Remember, when there are variables involved, you leave them space in case variables need to come out. And then if you recall from day 1, so how many times does the index 3 fit into 5? 1, so that means I have x to the 1 on the outside. And then if you have the 3 and 5, how many of the 5 is left over? 2, so you have x squared on the inside. Nope, you can't combine yet. This is 2x squared, this is 2x to the 5, so you can't quite simplify yet. Or can't add yet, but I can simplify this one. Can I simplify the 2, the number part? No, so I'm just going to leave some space. The numbers stay as they are. But I can simplify the exponent the same way I did for the previous one. 3 goes into 5 once with 2 remaining. Now they're like terms, right? Now what's interesting with the ones that have variables, you actually have to have like a double like term. The radicals need to be like terms, and the numbers in front need to be like terms in order to combine. So because this is 3x and this is 7x, are these two like terms? Yes, and so are the radicals. So then if I have 3x plus 7x, 10x, cube root of 2x squared. Again, don't forget to include the cube root or the cube root part. Now, if it didn't look like this, if it was 3x blah 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 plus 7 blah blah blah, is 3x and 7 like terms? No, for that one, you need both the outside parts to be like terms and the radicands to be like terms in order to combine them. So if that doesn't happen, you guys would have to write it. It's a little bit weird. You'd have to write it as 3x plus 7 in parentheses and then the radical here. I think there might be an example on the next page. But again, you have to be really careful that everything is like terms in order to combine them. So unfortunately, there is an extra detail to watch out for when there are variables. All right, go ahead and turn the page. A little bit more practice. All right, so I can obviously simplify square root of 50. What two numbers? 25 and 2. So it means a 5 comes on the outside to join the y. That, and then I have a 2 on the inside. All right. Now, can I simplify either of the x or the y out of the radical? No, so those have to stay put. All right. Now, can I simplify the 2 in the next one? No. So it's going to be 4. Leave some space just in case. Oh, that rhymed. Sorry. Then we have the 2. Can I simplify the x out? No, because the exponent is too small. However, remember what the index is for a square?
2.
2. So can I fit 2 into 3?
Yes.
How many times? So that means I have y to the 1, but how many was left over? 1. Cool. So, are the terms on the outside like terms?
Yes.
Awesome. Are the radicals themselves like terms? Yes. Awesome. That means I can combine everything. So if I have 5y minus 4y, it's 1y, and then the common radical stays the same. Okay? I'll try to put it. Alright, now cube root. How do I simplify 32? 8 and 4. So I circle the 4, right? Because it's a perfect square. This is a cube root, so I want to focus on the perfect cube, which is 8, which simplifies to 2 on the outside, 4 stays on the inside. How many times does the index 3 fit into the power of 3? With how many left over? Alright, so that's our first one simplified. Again, this is all just flashbacks to day 1. Alright, can I simplify the square root, cube root of 4? No. Alright, so this is simplified. It's not a square root, it's a cube root. That's why I can't simplify the 4. Alright, so now are the terms on the outside like terms? The 2x and the 8x, and then are the radicals like terms? Alright, so then I have 2x minus 8x on the outside. Cube root of 4. Remember the radical itself, once you get them to match, stays the same. Doesn't change. Alright, go ahead and give the last two a shot. See if you can figure those out. Alright, this is what you should get. So I gave you a little bit of a kind of flash forward kind of teaser on the previous page about what you do when you have the same radical, but the number or terms on the outside are not like terms. So you guys, when you simplified, it probably look like this, or hopefully look like this if you did it right. You've at least gotten this far, right? And so you get the radicals to be the same, but the numbers on the outside are not like terms. So whenever you have something like this, in order to write the answer, it's kind of like factoring a GCF, because they both have the cube root of 4x. It's kind of like you're dividing that away and writing these two terms as an expression in parentheses. So you're writing it as one term, so it looks like one term, but it's really like kind of factoring. Okay? So when you get this kind of scenario where the numbers, or terms, sorry, the terms in the front are not like terms, you just write the radical and then you have these two as an expression in parentheses. Okay?
Would you do the same if it was like the opposite? So like
Different
let's-
order?
Yeah.
Like x minus x?
No, like let's say, let's say inside the square root it's like 4, it's just 4, right? And the other one's just 4x.
No, then you can't combine them at all. Remember, because you can't combine them unless the radicals are the same. That's your main focus. But then, in addition, if the front are the same, you can add them, but if the front terms are not, then you're trying like this.
12 because it's x and
Yes. The radicands are not the, again, just like over here, you can't add them unless the insides are the same and the indices are the same. The radicands and the indices need to be the same. Alright, everybody okay with the general idea of add subtract? Alright, the last thing we're going to talk about is foiling. This is actually, I'm choosing to do this here because it brings multiply and addition and subtraction together. So we had to do the multiplication first last time, and then we had to learn addition and subtraction now. So now we actually have both things that we need for FOIL. So FOIL and distribution is going to work the exact same way as it normally would. It's just a little bit more complicated because we have radicals. So, alright, what's one mistake that you might make here?
On some square.
What do you mean?
On just square.
You might distribute the square. Can you distribute a square through this? No. What do you do instead? You FOIL. You write it twice. So everybody do that. Save yourself from making that mistake. Whenever you see something is squared, automatically write it twice. It times itself. So you don't accidentally try to distribute. Alright, so now we're going to FOIL. So remember first, outer, inner, last. So if I multiply the square root of 2 times the square root of 2, what do I get? Awesome. Square root of 4. Then I do square root of 2 times the negative square root of 6x. This is multiply. Negative square root of 12x. Remember, multiply, you can just straight up multiply stuff. Okay? Alright, then inner. So I have negative square root of 6 times another square root of 2. Another minus square root of 12x. Okay? And then last, negative square root of 6x times negative square root of 6x. Plus the square root of x squared. The other ways you can take shortcuts to make this look neater from the get-go, but if you need to go step by step, feel free. So just straightforward multiplying is what we get. Now your job is to simplify and combine everything that you can. Alright? Can I simplify the square root of 4? 2? Alright, can I simplify the square root of 12x? 4 and 3, right? So this becomes negative 2 square root of 3x, right? Okay, I have the exact same thing again. And then what would the square root of 36x squared be? It would actually be 6x, because the square root of 36 is 6, and the square root of x squared, they cancel each other, and then you have just x, alright? So, no more square root for that. So you do your multiplication line 1, then you do simplify line 2, and then combine line 3. Is there anything that I can combine? Two middle ones, right? So 2 minus what? 4 plus, looks nasty, but that's the answer. Alright, so you multiply everything, then you simplify everything you can, and then you add everything, or combine everything you can. Alright, 3-step process. Alright, let's do the same thing with this one. This is clearly FOIL. They've already written it, 2 binomials. Alright, so first times first, what do I get?
Well, should we subtract the numbers and numbers?
What?
Should we subtract the numbers first? Do 7
What
minus
numbers are there? There is no subtraction.
7
It's
minus
multiplying.
3 and 6 minus 4.
Oh my god. Those are not my terms. Did you just suggest doing like 5 square root of 5/7 or 5y?
No, I was
Like
just,
turning this into this?
no, I was saying just 7 minus 3. Or
No, they're not like terms. That's a mistake, man. 7 and 2 square root of 7y are not like terms, so you cannot do that. This is FOIL. We have to FOIL because they're already like terms, so you have to multiply them. So what's 7 times 6? 42, right? Is that correct? I don't know. Right, then outer, 7 times negative 4 square root of 5y. Okay, and then inner, so negative 2 square root of 5y times 6. Yep. Remember that when you multiply, numbers on the outside multiply together, numbers on the inside multiply together. Don't try to multiply the 6 times the 5. They're in different positions. And then last, square root 5y squared? 45 y squared. So you multiply the 5's together and the y's together.
Why didn't we do it there?
Say again? We did 36x squared. Alright, so I just multiply everything for the first line. Second line, I'm going to simplify everything that I can. So, what in here can I simplify? Only the term at the end, right? So I'm going to leave all this. But over here, what does the square root of 25y squared become? It's 5y. So square root of 25 is 5. Square root of y squared is y. Just square root of 5y. So this term is really 8 times 5y, which is 45. Because remember, whenever numbers on the outside of the radical, it's really multiplying. So when you simplify that, it's still 8 times that. So it becomes 41. Alright, now I can combine like terms. So 42 is by itself. Forward back. Is there anything that is like terms? The 2 middle ones? So that gives me negative 28 combined with negative 12. 5y. Remember, when you're adding or subtracting, the radical itself doesn't change. It's just the numbers on the outside of combine. And then plus 40y. Okay? These last two are special cases, so I'm going to do them. Well, not special cases, but Alright, so we have another foil right here. What's interesting about the setup,
It looks like
they're like the same, but they're opposites, right? This is kind of like what it looks like when we factor perfect squares, right? So when you see something like this, can you kind of visualize what it might look like, given our history with factoring perfect squares? X squared minus something, right? So with that little kind of hint in your mind, it will guide you towards what the final answer should look like. So we're going to FOIL, so first times first, x squared, outer, x times square root of 5. You just link them, just acting linked together. And then negative square root of 5 times x. Right, you always write the variable first. And then negative square root of 5 times positive square root of 5. Negative square root of 25, right? Okay. Then we simplify what we can. X squared stays. The two middle terms can't simplify. What about the square root of 25? Okay. Can I combine any like terms? What?
Oh wait, no you can't.
Yes, again. The two middle terms. They cancel. You can combine them, but they cancel and become 0. So then I just have x squared minus 5.
Is that gonna work out like that in every case with the opposites?
Yes.
So you
If I
can
remember
just-
correctly, those are called conjugates. Whenever you have a binomial like this, and then you have the same one but a different sign, they're conjugates of each other. So these will end up canceling. Again, just like we were talking about with factoring, if it was the square root of negative 4 and asked you to square that, you guys know the square root of 4 is 2. So you would do x plus 2x minus 2. Because 5 isn't a perfect square, the square root of 5 is just square root of 5. So when you factor it, negative square root of 5 is positive square root of 5.
So if I replace it with 3, you automatically
Square root of 3.
Mhm.
It's taking our previous understanding of, oops, I erased it. Our understanding of factoring and kind of applying it here. Oh, wow. Alright. Now this last one is not FOIL, it's distribution. You guys still need to know how to do distribution as well. So I'm just going to distribute this through each term. If I multiply 2 square root of 2 times the square root of 5. Awesome. And then 2 square root of 2 times 2. Awesome. Can I simplify either of those?